Welcome back to Math Solver 1117 Ultimate Hub, where maths turns into magic. Here every complex question gets a crystal clear solution with smart tricks. Stay tuned because your success in exam starts from here. In this video, we will consider most important theorem of fundamental in calculus, and this theorem will be helpful in study the behavior of function, that is Rolle's theorem. First of all, I will explain the statement of this theorem, then we will prove this. So for this purpose, grab your pen and paper and write down the statement, that is, let's consider f be a function. Then there are two situations for function f. First one be f is continuous and the second one is continuous on interval that is closed ab, and other condition for this is differentiable. This function is f is differentiable on open interval. This bracket shows open and this bracket shows close. Open interval AB, and the third condition for this is f of a, the value of the function at a point equals value of the function at b point. Then if three conditions are satisfied, then there exists, this sign shows there exists at least one point, that is C, and condition for C is C belongs to open interval AB, and condition for C is such that S dot T means such that derivative of this function f at point C will be 0. This is the condition. If this condition is satisfied, then we will say that Rolle's theorem is valid in any question. Now we will prove this. So we will write that since f is continuous on closed interval AB, then since f is continuous, this is given in the statement. So we will write this again, that since f is continuous on closed interval AB, and this is closed interval. Closed interval means it is bounded. It is bounded. Then it is bounded, it's mean it is bounded and there is in and attains its bounds. If it attains its bound, then we will consider let capital M and small m be the supremum and the infimum respectively, because condition is that this is bounded. So supremum and the infimum are exist. Supremum and infimum. Capital M is supremum and small m is infimum. You know, these shows upper least bound and the lower least bound. Infimum of f. Then we have two conditions. one is capital M equals small m, means supremum and infimum are equal, and the other one is capital M is not equal small m. These are the two possible cases. First we take one case and then second case. Now first of all, case 1, that is if capital M equals small m. It means supremum and infimum both are equal. So we will say that the function is constant. If both supremum and infimum are equal, we will say the function is constant on closed interval a b. When a constant function, we will say its derivative will be 0. Derivative vanishes because derivative of a constant function is always 0 at each point of interval, because we are discussing here interval close a b. So vanishes at each point of the interval. So we will say theorem is valid. Theorem is true in this case. Now we will discuss the second case. If capital M is not equal small m, means supremum and infimum are not equal, then at least one of them is different from the equal values of f of a and f of b. Then we will say let capital M is not equals f of a, that is equals to f of b. So it's mean f attains its supremum on AB, because we considered that capital M is the supremum, but M is not equal at f of a and f of b. So it means that capital M equals f of c, and condition for c is c belongs to closed interval a and b. Then because of the situation M is not equal f of b, then we will see that c must be different from a and b, because M equals f of c, so c must be different, M not equal f of a and f of b, which implies that c must belongs to open interval a and b, because c is not equal f of a and f of b, so c belongs to open interval a and b. Now consider let h be a positive real number. H is positive real number, and condition for this is such that c minus h and the c plus h both lie in open interval a and b. Condition for h is this. Then we will say that f of c plus h will be less than or equal to f of c, and f of c minus h will also less than or equal f of c. And since we know that f of c equals capital M, that is supremum, and M is the supremum of f, which implies that f of c plus h minus f of c divided by h is less than or equal to 0. Similarly, we will write that f of c minus h minus f of c for both functions divided by h is also less than or equal to 0, which implies that we have a new case, that is f of c plus minus h and the minus f of c and divided by minus h is greater than or equal to 0. And now we will take the limit of this, h approaches to 0, which implies that this is the definition of derivative. So f of c will be less than or equal to 0 in the previous one, and for this one will be greater than or equal to 0 from this one. So if a value is less than or greater than some same value, we will say that f of c is equal 0. So this is the proof of this theorem. I hope you understand. Now I will solve an example to elaborate this theorem, that how you will apply this theorem on your questions and check the behavior of a function, is its derivative is possible or not. So now I will solve the application of this theorem, because many students say that how we will apply these concepts, these are applicable. So example for this is f of x equals 1 minus x raised to power 2 by 3, and this is continuous on interval minus 1 to 1, and this is a closed interval. So we will verify the theorem on this. Verify Rolle's theorem on this. So we will apply, since f of minus 1, when we put minus 1 in this, so we get answer 0, and when we put f of 1, answer is 0. So first condition is satisfied, that at minus 1 its function value is 0, means condition f of a equals f of b, that is applicable. Now for second one, dash at this value derivative at 0, if we want to check, then 1 minus derivative of this, first of all we will calculate. So f dash of x equals this will be 0 minus 2 by 3 in the start, and x raised to power minus 1 by 3. Now this will become minus 2 by 3 x raised to power 1 by 3. Now put the value at x equals 0, we will get f dash of 0 equals 2 by 0, that is undefined. So f is not differentiable, that's why we will say that Rolle's theorem not valid. So this is the application, just you have to check the derivative at a specific point. If you found this video helpful, subscribe Math Solver 1117 and also hit the bell icon to get notification for all upcoming videos. In the next video, we will solve another important theorem that will explain the behavior of function, that is the mean value theorem. So tell us in the comment section which theorem you want to be studied first. Best of luck for your exam. Stay tuned.